Okay, guys. So what we're going to do is another part to Lecture 2. So Lecture 2, Part 2, Derivatives of Logarithms. And so in the last lecture, we just kind of went over an intro to logarithms in case you needed it. In this section, what we're going to do is we're actually going to find derivatives of logarithmic functions. Now, what I'm not going to do right now is derive the formula for the derivative of a logarithm. And the reason I'm not going to do that is because the best way to do it is with the formula for the derivative of an inverse function, and we don't have that yet. So we'll have that in, I don't know, like 1 or 2 days, something like that, by Monday anyway, at least. So I'm just going to tell you what the derivative of the logarithm is. So the derivative of the natural log of x is just 1 over x. And there you go. The derivative of any other logarithm, so log base a of x, that one is 1 over x, and then log base a. Wait, log base a, I don't know what I'm doing, hold on. ln a. Okay, so basically what this does right here is it corrects for the fact that it wasn't a natural log. This is similar to when you take the derivative of an exponential base a, which you saw in the last set of notes, last 2 sets ago notes, lecture 1. Okay, so really what I wrote here is just all you need to know in order to do this section. But, you know, the problems can be pretty tricky. So let's start out with a couple here. So let's just say evaluate. And I'm going to say like ddx ln 3x ddx ln 3 plus x. So we're going to do both of these. Make that 3 a little bit better. And let's just try to use the formula. Now, both of these involve the chain rule, right? Which you all know because you've taken Calculus 1. So the formula, of course, is just this. The derivative of the natural log x is 1 over x. So when you're taking the derivative of ln 3x, that's pretty straightforward. You would say that that is just 1 over 3x, right? But then you have to multiply by the derivative of what's inside because of the chain rule. So like a 3x prime, right? And that's chain rule. Well, what's the result? The derivative of 3x is 3. So you get 3 over 3x, which is just 1 over x. So the derivative of natural log 3x is actually just 1 over x, no 3. Now that's confusing to people. People screw that up a lot. Why does it work out that way? And the reason it works out that way is you have to think in terms of the rules for logarithms, right? Recall, we could have done this, or ddx ln 3x is, using the log rules, you can split up a multiplied logarithm like that into natural log 3 plus natural log x, right? And then what's the derivative of natural log 3? It's 0. It's 0 because natural log of 3 is just a number. So, and we know that the derivative of a number is 0. So ddx of ln 3 is 0, and ddx of ln x is 1 over x. So that's another way to do it, okay, without the chain rule. But that's surprising to people, right? You're so used to having, like, when you have not, like, the derivative of 3x is 3. The derivative of sine 3x is 3 cosine 3x. So you're used to having that 3 involved, but not for logs because of what we just saw. However, why my pen not work? Okay. For this one here, d dx of ln 3 plus x, there's not a log rule that applies. So there you just have to do 1 over 3 plus x times 3 plus x prime for your chain rule. And then what's the derivative of 3 plus x? It's just 1. So that's all you get there. Okay, and so these are not that hard when you first start them. However, your book is going to make them get rapidly more complicated, right? So let's do one, and then I'll do a complicated one. So let's say evaluate well, I'll change the language. Let's say y prime if y equals, let's go with log base 2 of sine x. Okay. So when you're doing that derivative, then you're going to need the rule for the derivative and then also the chain rule. So how do we take the derivative of log base 2? Well, we look back up the formula. Of course, it's right here. 1 over x ln a. And our a is 2. So we're going to have 1 over x, except that it's not x, right? Because we have a sine x there. So when you do the derivative, it's going to be 1 over sine x ln 2, right? That's the thing you have to add because it's not a natural log. And then for your chain rule, that's multiplied, you need to take the derivative of what's inside. So what's the derivative of sine x? It's cosine. So you get cosine x over sine x ln 2. And that's your derivative. And so that's not that complicated, but you got to remember your chain rules whenever the thing inside is not just an x. And you got to remember what to do with the 2, which is just add this extra ln 2 there. Yeah. Now what else can you do here? You could simplify this a little bit, couldn't you? You could say you have a cosine over a sine. Well, what's a cosine over a sine? That's like a cotangent. So you could actually say that this is 1 over ln 2 cotangent x, if you wanted. Why? I don't know. But you could do it. So, yeah. It's getting a little more complicated. Now, what the book is going to do is they're going to give you ones like this. Find r prime of x if r is ln parentheses x to the 4/3 cosine x over 7x plus 6. Okay? Now, what's the point of this? I mean, that looks complicated, and it is complicated. So why are they making you do it? Right? The reason they're making you do it is because they want you to realize that you can use all of those log rules to simplify the logarithm before you take the derivative. So use log rules to simplify first. Then take the derivative. If you don't do that, your life will be hard. You'll have to use quotient rule and all kinds of stuff. You don't want to, so do this. All right, so how are we going to do it? So r of x is what they wrote there, but we need to use the log rules. So let's first use the log rule for division. So we can split it up into natural log x to the 4/3 cosine x minus natural log 7x plus 6. Then we can use the log rule for multiplication in a log and turn this into natural log x to the 4/3 plus natural log cosine x minus natural log 7x plus 6. Then we can use the log rule that lets us bring a power down in front and have 4/3 ln x plus ln cosine x minus ln 7x plus 6. Okay, and you do all of that before you go and you take any derivatives. That way, when you do take the derivatives, it will be easier. So now we're finally going to take the derivative. So what's the derivative of 4/3 ln x? It's 4/3 times, well, the derivative of ln x, which we know is just 1 over x. Then we've got ln cosine x. And we know how to handle that now too, right? It should be 1 over cosine x. But then the chain rule makes you multiply by the derivative of what's inside. So what's the derivative of the cosine function? Negative sign. Then on the last one, we've got the natural log of 7x plus 6. Well, how do we do that? Well, it's going to be 1 over 7x plus 6 times the derivative of what's inside. So what's the derivative of 7x plus 6? Just 7. So you write it that way, and then now you just need to kind of make it a little prettier. So the first one simplifies into 4 over 3x. The second one, it's negative sine over cosine, but sine over cosine is tangent. So I'm going to say tangent there. And on the last one, not a lot you can do, so you just kind of rewrite it. That's probably as nice as you can write that one. Okay, so I did actually just do that on the computer, and they didn't bother writing a tangent there. They just left it sine over cosine. Yeah. Let's see here. Looking for something more interesting. I don't think there are any, actually. Come on now. I guess I'll do one of those because there's a million of them here. For some reason, they really like the problems like this. Evaluate ddx ln. They'd like to put a polynomial in here, like 3x to the 3 plus 5x squared plus 2x plus 4. And, you know, that looks a lot more complicated than it is. Since log rules don't apply to sums, you don't do any log rules. All you have to do to evaluate this derivative is use the basic formula 1 over x, which this whole thing is your x in that case. So 1 over 3x cubed plus 5x squared plus 2x plus 4 times, and then your chain rule just makes you put the derivative of what's inside. But the derivative of a polynomial is really easy, right? So this derivative is just 9x squared plus 10x plus 2. So you do that, and then you just put them together. And that's all you're doing. And for some reason, Newton Alta really likes that type of question. So they'll make you do a bunch. I'm waiting for it to ask me something else here. Okay. Yeah, I mean, I'll do one more. derivative of h of x equals log base 8 5x cubed plus 3x. So that's just about the same thing as what we were just doing, but this time it's a log base 8. So h prime, how do you do it? Well, again, it's 1 over x, but this whole thing's your x, like that. But you have to remember what to do with that 8. And what you do with that 8 is that, right? So you have to tack on this extra ln 8 because it's not base e. And then you continue on and you multiply by your derivative of what's inside, which is 15x squared plus 3. So it's pretty straightforward. The main thing, again, is just making sure that you understand where that natural log 8 is supposed to go, right? Specifically, you need those parentheses around the 5x cubed plus 3x. Otherwise, you'll be making a mistake. And yeah. Okay, well, I keep doing these derivatives on the computer and I'm not seeing anything come up any different. So I think I'm just about done here. But what I will say is specifically this example here, find r prime of x, where it's the natural log, x to the 4/3 cosine x, 7x plus 6, that kind of thing, where I use the log rules that we talked about in the previous lecture. That's pretty important. When you see a complicated derivative that they want you to evaluate, think about using those log rules and take it apart as much as possible, just to save yourself. Like even right on this right here, like this term, you could probably take the derivative of, right? Directly, without doing any more rules. You could say like 1 over x to the 4/3 times, and then the derivative of x to the 4/3 is 4/3 x to the 1/3, right? So you could do, like this derivative could be 1 over x to the 4/3 times 4/3 x to the 1/3. So you can do that derivative, but why, right? You can do one more log rule, which lets you take the power 4/3 down in front, and then the derivative is really easy. So what I just highlighted is the same as that 1 over x to the 4/3, 4/3 x to the 1/3. But you don't want to do it the way that I did it right here, do you? Because it's just more work, more writing, that kind of thing. So use all the log rules that you can, and makes the homework easier. But yeah, that's my only advice. You're just going to be taking a bunch of derivatives like this, it looks like. For some reason, the exponential homework was really product rule and quotient rule heavy. And this one's not at all. Anyway. Okay, so that's it. Hit stop.